And with that, we will start the last session presentation of the workshop. I would let Jason to take from here.
Thanks, Jorge. As Jorge notes, this is the last talk of this workshop. We do want to extend our gratitude to everybody for tuning in and asking thoughtful questions over the past 2 days that we've been holding this. I think it's been really good to see people thinking critically about some of these topics. And along those lines, we did want to feature a little bit of a talk on BGP and routing security. Even though we're not going to do any hands-on sessions to this, it's a little bit of a prelude to some of the work that EPOC and others are participating in. So with that, I'd like to introduce Hans Addleman, who's going to be giving this talk today. Hans is from Indiana University International Networks, where he's the network architect and also a key member of the EPOC team, which is joint work with the SNET. Hans has had a long career in networking, joined the IU Global NOC in the early 2000s and has done a lot with networking and routing, open flow based networking, network security, technical training, list goes on and on. Along with that, he's also the SC23 SciNet chair, so he may roll a little bit of that information in near the end of his talk, as we are actively always seeking volunteers to participate with SciNet. So I will throw it over to Hans to lead us through a little bit of a discussion on routing and network security. And then after that, we will go into a little bit of a Q&A before we end for the day. So take it away, Hans.
And if I don't talk about SC and SciNet at the end, remind me, because that's a good bump. So today's been pretty great. We've done a lot of BGP basic stuff. We've learned a lot of interesting things. I wanted to end the day and kind of scare everybody. Maybe not really scare, but BGP, and real quick, just a quick agenda for you later if you want to go through it. BGP, Brenna said earlier in the day, it does make the internet work. There are 74,000 autonomous systems or different networks out there. Over 1 million advertised IPv4 routes, almost 200,000 V6 routes, and more added every day. Without BGP, none of these networks would talk to each other. And because of that, BGP is a really big attack vector for people, right? There's a lot of different things people could do if they can assault BGP, or even maybe it's not a malicious attack, maybe it's just a human error or misconfiguration. No matter what, we can cause real damage to the entire internet with very few keystrokes. So, and each router, I say here, running BGP builds its own routing table with best path information to whatever subset of the internet it can get to. Hopefully your computer or whatever computer you're on somehow can get to almost anything that's currently active on the internet. Thinking about that kind of blows my mind, right? It's big. And what's even a little scarier is BGP is a fairly old protocol, right? It's been in use since 1994. You can go and read the RFC if you'd like. And back then, security was not a concern. Oh, excuse me. The trees are trying to kill me. So I've taken some Claritin and some other things to help, and it's unfortunately left me a little tired. Anyways, BGP is old. There was no security baked in. If another router advertises and says, hey, I can get you to this address, your BGP by default will believe that and send traffic to that guy, whether it's truth or maybe a bad actor. And then your BGP instance can also, by default, possibly re-advertise that bad or good information to other peers, depending on where you sit in the network world. So there are three pretty big things that happen, and have happened for years now: hijacking, leaking, spoofing, and we'll get into each one of these. And I'll talk about what manners is in a little bit. However, just in 2018, they recorded over 10,000 routing outages or attacks or misconfigurations. So, these are ongoing. And, as I say, there 40% of all of these incidents are believed to be attacks. And, like I said at the beginning, one small misconfiguration on your campus's BGP instance could possibly scale to become global problems. Personally, myself, I've done this. I've brought, on a certain internet provider that I used to work for, I once brought most of the network traffic from all over the country to Cleveland and then promptly black holed it. That was a learning experience for me, and it was just a misconfiguration. So that was fun. Lasted about 10 minutes, and I thought my heart was going to stop. So route prefix hijacking. When a network advertises or originates a route that belongs to another network without their permission. Like I said, not always malicious, right? You could have an IP address that's awful close to another person's IP address, and maybe you just misconfigure it. And there, I've through the entire slide deck, I've put a lot of references. Feel free to grab the slide deck. I believe Jorge's already posted it, and take a look at some of that. There's deep dives for each one of these slides, or most of the slides. So hijacking, how it works, right? So, you learned how to advertise your prefixes earlier today. And so your legal advertisement down here, AS1, he says, hey, I have this /22 I'd like to advertise out, and it's going out. And as we talked about earlier, the AS path is additive. And so you get up to AS4 and he says, oh, I know how to get there. I go 3, 2, 1. Well, except let's say there's an illegal announcement, whether it's a hacker or just a misconfiguration. He advertises that same IP address, that same /22, and it gets to AS4, and hey, look at that. That's a shorter AS path, and we learned that by default, BGP will go for that shorter AS path, and we learned why that may not be right for R&E networks anymore. But in this example, he said, oh, hey, I'm going to go this way. And so all traffic destined to that /22 from this AS goes right to AS5 instead of AS1. Now, whether that's malicious and he's sniffing that traffic, or just possibly even a campus network that had a misconfiguration, sucked in a bunch of extra traffic, and maybe AS5 is now, oh my goodness, I'm in trouble too, because it's, may have overwhelmed its pipes with all this added traffic coming to it that it wasn't expecting. Maybe here, a more specific prefix. So the hacker, instead of getting it via AS path, he puts a /23, which is a more specific prefix than a 22. So over here in the RIB, the routing information table of AS4, he says, oh, I have, I can go to the AS20 or the 20/23 or the /22, and I'm going to send my traffic to AS5 for that /23. So an interesting example, and this was back in 2008, but it was pretty crazy because it affected YouTube and Google. This is a very large one. So over time, Google, this is one of their, YouTube, this is one of their major IP ranges, the /22. And sometime on Sunday, the 24th, AS17557 starts to announce a /24, which is a subset and a more specific subset, like we just talked about, of that /22. Routers around the world receive that announcement, and a whole bunch of YouTube traffic is then directed to Pakistan. YouTube at this point, about an hour, a little over an hour later, notices something's going on, starts announcing 2 /24s to try to get around that, and be more specific than the illegal advertisement. And they do get some traffic back. At that point, 10 minutes later, they realize, oh, that's not specific enough. Let's get a little more specific. And as routers around the world grab those advertisements, things start going slowly back to normal. And then, of course, PCCW noticed there was a problem, made the AS path longer towards Pakistan, and that also helped traffic go to YouTube. And then, of course, another hour later, or about 45 minutes later, Pakistan realizes the problem and stops that hijack. And here's where the different case studies. This is a really interesting thing that happened. This wasn't actually really an attack. This was political in nature, I believe, where Pakistan wanted to limit some YouTube, and they tried to do that in their country with some BGP manipulation, and unfortunately caused a worldwide issue. There's a lot more, like I said, in the RIPE and the CNET articles there. Other hijacking examples. The 2018 one of Amazon DNS was interesting. That was actually malicious. They were looking at getting not PayPal, but some kind. They were grabbing payment stuff. So there was actually they'd hijacked these routes and were taking payment information into their network. And I assume at that point, looking at that payment information and doing nefarious things with it. 2020. Rostelcom hijacks internet traffic for Google, AWS, Cloudflare, and many others. This lasted only for a few minutes, but it was a pretty big. And they think, this one they think was a hijack, but we can't be sure. It may have just been a misconfiguration. So how do we fix these hijackings, right? We've talked about. We see this is a pretty big issue. We know there's hundreds of attacks a year, thousands of attacks a year. Well, RPKI, Resource Public Key Infrastructure, comes to the rescue. So there are regional internet registries, and these are the people that assign IP addresses to AS numbers. So if you come and say, hey, I want to get on the internet, you talk to one of these RIRs, and they say, okay, well, here's your AS number. Here's an IP address range that you can have. You're allowed to use these. And then, in the past, before RPKI or anything like that, we just trusted everybody and said, okay, that's mine, thanks, I'm going to advertise it. So now there's a few things that you can do. So with certificates and things like that, you can do route origin authorization that show, and that other people can check via RPKI to make sure that you're actually authorized to advertise that IP address. Allows you to verify addresses advertised to you from other people. This is just starting, well, not just starting, it's been around for a few years. You can see a nice little overview of RPKI there from Noction. But basically with this system, you can take a look at an incoming route and tell your router, hey, that's a valid, invalid, or unknown. And create route policy depending on those results, right? So valid, of course, you're probably going to want to accept. Invalid or unknown. Invalid, maybe you want to just dump on the floor. Unknown, that's up to you what you want to do with that. I would really recommend is you bring up RPKI. Don't do anything with route policy yet. Just start looking at them and grabbing in your logs what it may be, right? So don't do valid or invalid for a while. Play with it, test it, put it in a test mode where you can see what your validator thinks it's doing and what your router thinks it's getting before actually going production with that. But anyways, it allows you to not only reject on wrong AS, wrong prefix, but also to fix like the more specific thing that we saw earlier. You can do that as well. So inside that route origin authorization, we'll actually say, Hans Addleman is AS number 15. He's allowed to do this prefix up to a /25. If you see anything more specific than a /25, that's probably not Hans. So looking at a different thing, a route leak. This is a different kind of attack or misconfiguration. And there's an RFC that describes this as well. And luckily for everything here, there is a lot of great tutorials, best operational practices, and RFCs that can help mitigate most of this. So a route leak is the propagation of routing announcements beyond their intended scope. In a campus case, if you were, say, multi-homed, or a campus or a stub network, as they're sometimes called, if you were multi-home, meaning like you had Verizon as one of your transit providers and say AT&T as another transit provider, you would take in, and actually I think I should, yeah. So you would take in, say, AS2's prefixes and re-advertise them to AS1, right? And if you're if you're like connected to a couple of tier 1s or even tier 2 service providers, when you do that, and if there's nothing, no validation or anything here, and AS1 accepts you as the best path to all the networks behind AS2, your pipes are going to get clogged very, very fast, right? So it's a good idea not, and I think I say this on the next slide. Oh, that's an example. Anyways, that's what a route leak looks like, right? So you're leaking someone else's routes out another of your network connections that you should not be originating. So this one's interesting. In 2017, as an example, Rostelcom again, they had a route leak that, and much like the Amazon DNS one, targeted e-commerce services, but instead of grabbing traffic and kind of black holing it and looking at it, what they did was a little more insidious. They took that traffic, took it into their network, and then passed it along, right? So every one of these e-commerce transactions that went from A to B went through their network, and they were able, to grab that possibly and leave it to the side for later inspection or stealing of information, whatever might have happened there. Now, of course, this could have been a misconfiguration, like I've said, but it's just a pretty good example of what can happen with a route leak and how dangerous that can be. It can be more than just filling up your campus's pipes, right? It can be actually malicious. So route policy to fix leaks. There's a really great BGP operations and security RFC written to do just this, with a good primer there as well for best practices. The simplest thing is to not only originate what you have authority to originate, right? Don't originate anyone else's prefix without authorization. And I say that, so here's a couple of different things from the BCP. Loose inbound filtering, not only don't advertise prefixes you don't own, but don't accept your own prefixes from another peer, right? That's probably bad. Filtering bogons, which are addresses not assigned. IPv4, as I say, not so much anymore, because I believe we are completely exhausted and all IPv4 space has been assigned. But there is a massive amount of empty IPv6 space out there. And there are bogon lists out there that you can just crawl and programmatically put into your route policy. Be careful of more specifics. I know, and this is a little weird in the RNE world, I know that a number of us do accept more than a /24 or a /48 for B6, but it's just something to be thoughtful about as you're writing your route policy. And then, of course, you can use strict filtering using things like RADDB and other places where people will actually put up their routing, their prefixes and their routes. You can actually use scripts and tools to validate that kind of thing against the route registries. And that's all covered in the operations and security RFC. I really recommend taking a read of that. Outbound, like I said, only originate what you can, or only advertise what you originate. Don't advertise private space. We do see quite a bit of that. And I'll show you where you can see things like that happening. That's RFC 1918. So, your 192, 168, your 10.0s, whatever. Don't just write a little bit of route policy to not advertise those. And don't advertise your management networks, your internal networks, things like that. And do not advertise the default route. That'll cause you to leak real bad. IP spoofing. This is mainly used in DDoS attacks. An attacker, can create and send an IP packet with a false source address. This is, very commonly used in DNS, Memcached, NTP. There's just so many different things that are vulnerable to this kind of thing. And this was interesting. Just last November, Microsoft published this blog that they detected and mitigated a 3.47 terabits per second, 340 million packet per second, 15-minute long DDoS attack using UDP reflection. So, I mean, they claim, that this is the biggest attack that anyone has ever seen, and that is that. I mean, look at that. That's a pretty massive attack. They don't say who were the attackers, of course, but it's definitely worth checking out that blog and doing your best to mitigate IP spoofing, and that'll get you on the way to helping mitigate DDoSes on your network. it won't fully help you, but it gets you some way there. And in this, URPF is really important. Universal reverse path forwarding. The router will actually check its forwarding information base for a source address in each packet. And if the router can't get to itself, like if it can't find that prefix that it's about to send out on the network or to someone else, in its forwarding table, it will just drop that packet because that's most likely spoofed. Can be done with ACLs as well. That can require some manual configuration. And amazingly enough, there is a wonderful RFC, and even better than the RFC, there's this BCP 38 that directly addresses how to fix or how to best mitigate spoofing and DDoSes on your network. This is a really great page. Both of those are really great. So like I said, this all might seem very scary, but it's not terrible, right? There are ways to mitigate most of this. BGP Sec, we're not there yet, but I thought it was worth mentioning. You can go and read the RFCs. There are a few open source projects doing this now, but no major router supporting this yet. So an RPKI will validate that NAS is allowed to source a prefix, to advertise a prefix, but it does not validate the entire path. So there could be attackers injecting things along the way into an AS path to change routing. BGP Sec is here to help solve that. We hope that ITF is working on this right now. So hopefully soon we'll see something that will help you verify the entire path and kind of get rid of the man in the middle BGP attacks that we could be seeing. And of course, we talked about this. Someone mentioned this a little bit earlier, asking about BGP communities and how secure they are. BGP, forever, or for quite a while now, you've been able to configure a password and MD5 hash your packets, between the BGP peers. It's a good idea. Unfortunately, make sure you have those passwords written down somewhere that all of your after hours engineers can get to, because if something untoward happens in the middle of the night, you don't have that password written down somewhere, and he may need to bring up a new peering with that peer. It can cause problems. But yeah, so that helps secure the BGP peers talking to each other directly. That does not help for multi-hop BGP peers, and neither does GTSM, but it helps a little bit. So GTSM is interesting. It sets the time to live of BGP packets to 255 because most of the time our BGP peers are connected directly. That TTL should never drop. So if the router sees that the TTL on that packet is less than 255, it will just drop it and say, no, I'm not going to bring up BGP with that. So I've talked about, there's a bunch of different ways, BCPs, RFCs, and stuff to help fix all this, but also there's this group now, the Mutually Agreed Norms for Routing Security, or MANRS. I really highly suggest you check out their website. Their goal is to improve the security and reliability of the global internet routing system. And they have programs, training tutorials, best practices, everything you would need to put the best security practices in place for your routed and BGP external infrastructure. Not only for campus and network operators, sub-network operators, exchange point operators, even CDNs. So they have programs for everybody. These guys, and I really like their training programs. I've gone through a few of them, and they are really handy. They're very easy, very well written, so it's easy to learn quickly some of these best practices. I just wanted to show a few things. You can join MANRS and say, hey, I am a MANRS compliant network. And as a campus or network operator, an end network operator, these are the things they asked for you, right? They would like you to do filtering. They'd like you to do that anti-spoofing. They'd like you to be part of the coordination effort and global validation. So, whether you're publishing your data on an IRR or using RPKI, things like that, you can read a lot more about them at their website and a few other places. And like I said, their tutorials are amazing. They're right, there's a link to them right there. I know Brenna talked about this earlier, International Working Group. We're not exactly focused on security, but we would love to talk to you about security if you have questions. This is truly an international team of, I think, almost 150 members now. We have a fairly active Slack, a fairly active mailing list, talking about all sorts of different things. And I know Brenna went through, we're actually working on cases to improve performance, but we're happy to talk to you about not only the engineering focus, but also policy focus. Do you have questions about security policy for BGP or routing, things like that? We are happy to talk about that and help you, direct you in the right direction. So there's how you can join our routing group. I know we threw Brenna's name in the chat earlier. And this is, so these are some of those interesting, I just want to put this here, interesting routing and BGP resources. And I really enjoy route views. Route views is amazing. You can see routing tables over the years, daily or better than daily snapshots, going back years for lots of different networks that participate in route views. But you can also log into the route views. I think it's Quagga, one of their route views router, let's say, and actually get a live view of what they see of the routing tables of the world, right? So if you're bringing something new up in BGP and you want to see what the outside world thinks of what you're advertising, route views can help you with that. Twitter.com, the BGP stream Twitter handle is really great. It's a live stream of attacks, hijacks, and everything, and people, misconfiguring attacks, whatever. It's really fun, quote unquote, Twitter follower. And BGP stuff is just super interesting. You can see all kinds of stuff. It's like route views, not as connected as route views, but it has some interesting graphical views that I really enjoy. And then a couple other, you can see how the BGP tables are doing as well. A daily snapshot, he'll say, oh, I've seen this many prefixes on V4 and this many prefixes on V6, and this changed that much from the last time I saw them. So there's some interesting resources there I thought I'd point out. And, real quick, Epic, we are NSF funded. We're here to make researchers' data transfers go faster. We're here basically to answer any networking question you have. And if we can't solve that question or help you with that question, we will direct you to the right people that can. And just like the Ghostbusters, we are ready to believe you. Check us out, and thanks.
All right, thanks so much, Hans, for giving that great overview. It looks like there were a couple of questions that did come in during the chat. I'll see if I can go up here to the last one that wasn't answered. Brian had asked some questions, but thanks to Adair for answering some of those. Does manners require BGP passwords?
I don't believe they actually do, but I would leave that to one of the manners ambassadors. If you're interested in manners and you want to talk to someone, I can get you in touch with Steve Wallace. He's at IU and also a manners ambassador, so I'd be happy to get you in touch with him.
On the subject of BGP passwords, I in a previous position at a MSO and ISP, I designed internet circuits that used BGP, and after a period of time, we started requiring MD5 BGP passwords, and I followed along with that, and I thought I could see a reason why, but I really couldn't ever. I never really got a great explanation of what exactly the benefit of that is, because at least with the way that I've always seen and set up BGP, from the provider side, we always at the University of Nebraska and previously, we've always set up filters to only accept advertisements that we expect from the member, from the customer, that they get this 20 and this 25 or whatnot, So I guess I don't really understand the benefit to the internet or the benefit to the network of requiring a password.
Well, as a network operator for many years myself, I agree with you. And honestly, I would almost say that I've had more issues with BB, and that's why I said always have that password written down from personal experience. I've seen that password
Yeah.
bite me more often than once. I think in a lot of ways, there in a multi-hop environment, I think it makes a lot of sense for man in the middle possible kind of things. Since without that MD5 overlay, your BGP updates are just zipping along in clear text. Now, if you're not multi-hopped and right next to each other, maybe that's okay. But with my networking security hat on, I could say, well, you're directly connected, but maybe there's an exchange operator switch in the middle, and maybe some bad actor were to get a hold of that, get a hold of some data on that switch between you two or something, or be able to see traffic from the switch between you two. With that password, you could stop that leak there. And now, granted, that is a corner case, let's call it. But
So I guess my understanding of setting up an encrypted password, that just password protects the BGP establishment. Is that right? Or is it also encrypting
no.
other types of traffic or other types of communication?
So the way I've read it is that it encrypts every update that goes out. So it's, I could be wrong, but that's the way I've always read it.
Okay.
So if someone can verify that one way or the other, or I can go back and do some more research, and happy to hit you up offline. But the way I've understood it is that it hashes everything that goes out.
So even like route updates.
Yes, that's
Okay.
the way I always understood it. So I could be terribly wrong, but that's the way I understood it.
Okay, thank you.
No, thank you.
And one thing to note here is that Bill put in the chat room that they've had 0 outages from attempted BGP hijacks, but multiple outages from forgotten passwords during maintenance. So,
Which is, yes, Bill is 100% right. And like I said, as a network operator, I have had that exact same problem. But it was network security talk, BGP talk. I wanted to just make sure that was out there and understood. So I can definitely be swayed either direction.
okay.
So-
And next question that has not been answered yet. It seems like some of the IGPs have implemented security pretty well. Is BGP Sec using other routing protocol security implementations as a model?
I don't know, honestly. I've not, there have been many times I've wanted to join ITF working groups, and I just realized how much time I don't have to do that, unfortunately. So there is a lot of the RFCs out there. You're welcome. Then I bet you that if it doesn't explain it in the RFC, I'm sure someone that is listed in that RFC would love to talk to people about it. And actually, that might be something Brenna and I we could get someone from the BGP Sec teams to come give a talk to the routing working group soon. That would be really interesting.
Yep. Okay. Well, that was all the questions that we had in the chat.
I see Michael
just
has
as
his hand. Michael has his hands up.
Sure, go ahead. And
I did. I actually was just going to make a very quick comment just related to the passwords. For anybody who doesn't already know me on here, I run both the network at AMNH and I'm the CISO. And so anybody that does know me know I fight with myself often based on the network operator on me, and I got my start as an ISP, and then the data security side of it. And I have been with, and specifically with Bill, because of a misconfigured password, had a BGP go down on more than one occasion. That being said, from the network security point of view and from our ability to do compliance and things like that, I think the main edge case is that we don't always know if we're directly connected to the peers or not. And that's
correct.
part of the question that we have to answer and part of the risk that we have to deal with for our institution, because there is a tremendous amount of trust within BGP, but there's also a tremendous cloud. I mean, everything is a cloud when you leave your own network. And so it becomes an issue of that little bit of extra, yes, a pain in the butt from the network operator. And believe me, I've wanted to rip more BGP passwords out just because they're a pain in the butt. But from our side and compliance and being able to sell the security and things like that, that is in part the reason why they're there. It gives us a level of trust that we would not have otherwise. And
For
so
sure.
your mileage may vary. I can be swayed probably more easily than some of my other CISO friends. But once you're kind of out connected to something that you can't verify what's on the other side of that line, those little extra help, little extra jumps give a level of comfort there. So it's
Michael,
but I would still do it.
You're talking about like a scenario not where like somebody is trying to connect on a different IP address or anything like that. You're talking about somebody spoofing that what you hope is your next hop, and then injecting different routes or
potentially. And I mean, again, it's a very edge casey kind of a thing. And I think the real issue here, and by the way, I do agree that MD5 is not useful as a hash algorithm anymore. But it's just like one other little step. So yes, it probably should be upgraded. But I just saw that comment. But I think the issue is just this actually came up to a certain extent in another conversation where people are now looking at all the different attacks that are hitting parts of the supply chain, things that we never thought about getting hit before are now getting injected in. So I think it's the not knowing, it's the level of trust that we're trying to establish. So it may seem like an unnecessary thing. And like I said, I'm kind of dubious about whether or not it really impacts it. I'm also just saying in terms of dealing with your CISO, who may not understand the networking on the same side of this, you may not win the fight of not putting them on there. And so I make it a habit of trying to put them on there. I know not every customer does. I know not every, provider does. In fact, I've had two of my providers, not NYSERNET, like actively say, well, we really don't normally put them on there. And we've still forced the issue. So once they're on there correctly, and if you use a decent way of maintaining that password, it's not that big of a deal.
Yeah, it's funny that you say some of the things you just said in the network security breakout. Nathaniel Mendoza, the CISO of TAC, was talking about just how much not only is he having to convince C-level people, but convincing lawyers and insurance people now is huge. And then trying to explain passwords and all this. And we were talking about maybe we do need to come up with a small working group that helps explain some of these more esoteric networking things in lawyer speak almost.
Yeah, and I would agree with that 1,001%. And I don't want to make this go on anymore in case people want to leave early. But the biggest challenge that I believe a lot of technologists have between the CISO suite and the, say, more traditional networking suites, and then with other C-levels and the compliance requirements and all the other things that we have to maintain, is understanding and being able to explain the risk and the reward on those. So if we're looking at it from a purely technical point of view, we can say, okay, this is somewhat dubious. However, our cyber insurance companies, our government contracts, our regulations that we have are expecting it. And so the CISO at that point says, okay, even if you could convince me, let's put it this way, you could convince me very easily right now as somebody who's run a network for years to dispense with this, to dispense with the MD5 passwords on BGP. There is going to be a checkbox someplace, somewhere, that if an auditor hits it, we're in bigger trouble. And I think that's if there's a security feature that we can leverage, that it isn't costing more, that we can put in there, that is what our cyber insurance carriers or our attorneys, or in an incident, every little ding that we would get potentially, even if it's a minor thing and it's not directly associated with whatever the incident is. These are all little things that kind of build up this wall here, and that's what the CISO is up against. They're constantly fighting what they don't know. So that's just a little perspective from the other side of this, from the left side of my brain versus the right side. And if I sound like I'm confused, it's because I've got both of them arguing in my head right now. But I'm trying to give the perspective from the other side.
So
I
What
would
we're up
very
against.
much appreciate.
Michael, I'm glad that you brought up the point about cybersecurity insurance. Are you aware of any companies that have policies out there that require BGP passwords? Has that ever come up?
Not that particular line, and just having, frankly, just redone all of our paperwork for our renewal.
Yeah.
Just literally a week ago. No, they're not specifically getting into that. What they are putting out there is, are you maintaining XYZ best practice here, best practice there? So if a best practice document along the way says, use an MD5 password on your BGP, and then you're not, it begins to make a case for your auditors, your cyber insurance, your incident responders, whatever it is, of what else are they not doing? It's that little corner of the wallpaper they start grabbing at. And that's ultimately what it comes down to. No, I don't believe the cyber insurance companies are getting that detailed, but it is a question of best practices here. Are you securing all these areas on your network? I will tell you that from 5 years ago, the documentation that we had to provide for our cyber insurance versus the documentation that I'm providing now is many times more expansive now than it was just a couple of years ago. And it just almost doubled the amount that I had to do over the last year just with all the hacks that have come up. So it's just a question of not risk elimination, it's a question of risk reduction. And in the minds of the people with the money and the cyber insurance companies, that's what they're going for.
Thanks.
Really appreciate that, Michael. Thanks.
All right. Looking back in the chat room, it looks like most of the other questions were answered. Does anybody have any others related to this topic? If not, we can move towards sort of the final phase of the workshop here, where we just open it up for any other general questions. Looks like there's one, Hans, if you want to read it out.
Oh, Kathy, thank you. So no, we didn't talk about SINET stuff, and I'll spend 5 minutes here real quick. So supercomputing, the supercomputing conference, SC22, is coming up here in November. The conference itself is in November, and then again, of course, in 2023. 2022 SINET is chaired by Matthew Zakauskas from Internet 2. 2023 SINET is chaired by yours truly. And we are always looking for volunteers of all levels. So SINET is a group of about 100-ish, sometimes more, network engineers, systems engineers, DevOps folks, and campus people, switches, Wi-Fi. Basically what SINET does is runs the network for the supercomputing conference. So not only the day-to-day Wi-Fi and wired needs of booths and all the convention attendees, but also we do bespoke builds for researchers and experimenters who come to show off demonstrations and things like that on the SC show floor. So in the past, we have, we like to claim we're the fastest temporary network in the world. Over the course of 2 weeks, we set up a network. We run this network as a production network for about 4 days and then tear it down in a day. We have brought anywhere from 2.5 to 4.5 terabits per second. Actually, I think Jason's year in 2018 was still our best, and I think that was 4.22 terabits per second into the show floor, into this convention center. And we do this in a new place every year. This year's coming up. It's going to be in Dallas, Texas. And like I said, we have availability on all our different teams, whether you want to do wide area networking, you're a wireless person, a fiber person, router person, whatever you may be, or even if you're interested in trying something new, if you're normally a router guy and you want to come do some layer 2 stuff or play around in the wireless world, we'll take you. It's a great experience. There's a lot of really great networking. I know, actually looking through the list, I know a lot of people in this. Hey, look, thank you, Adair. From my supercomputing experiences, you end up learning quite a bit. You get to play with contributors' latest and greatest technology. We have anywhere from 30 to 40. I think one year we even had $60 million worth of contributed gear, you know, from the biggest names in the industry, Ciena, Juniper, Cisco, whatever. And you get to work side by side with their systems people, and it's pretty great. So that's my pitch. If you want more information on SINET, hit me up and we can, and I'll put a link, my email, and also a link. Thank you, Adair, for the, and you can go there where Adair posted to see what teams are available and how to apply. And if you just want to talk about it, I'm happy to talk about it. And like I said, we will take, you know, from the day one most junior engineer up to senior engineer. I promise you'll learn something. Pitch over.
Great. Well, thank you, Hans. Jorge, I think